Hello, I'm Harshvardhan Chauhan. I'm a software engineer at Habana Labs, Intel, working on enabling deep learning models on Gaudi. Today I'm going to show you how you can set up Gaudi TensorFlow environment with just few commands, and then I will walk you through TensorFlow ResNet 50 keras training on ImageNet dataset. Let's get started. In this video, I'll be using a Gaudi based server. I'm assuming your device is set up with Gaudi device and driver firmware, and you are familiar with TensorFlow framework, ResNet 50 topology, and how to use a Docker. If you have not already set up the device or have any problem, please check out other setup and install resource from our website. The first step is to download the Docker image, as shown here in the command to download the Docker image from the vault that I'll be using. The vault is our public repository for all images and software content. The next step is to run the Docker container, and here is the command. There are few flags which a user can set for convenience of transfer of files from Docker container to the local system on which container is running. One can map a directory using flag -v to transfer training logs from container to the system or access other data files from system to inside the container. Also, one can use flag --work dir to set a default work directory. In my Docker container, there are 8 cards available, and all of them will be available for training. That's it. Everything we need to run TensorFlow model is ready now. You can also check out the Habana TensorFlow user guide to learn more about Habana TensorFlow integration and also learn how you can port your own models on Gaudi. Keep watching if you would like to learn more about how to run ResNet 50 keras training from our model reference repository on GitHub. We'll start by cloning the model reference repository from GitHub. You can use hlsmi command to get the right branch version. So to clone the model references, this is the command. We can see that the repository is cloned and available in the root directory. Here is the repository. We need to add the path to model references to our Python path environment variable. We will also set the Python variable to the right version of Python library. For ResNet keras model, we'll go to the path shown here. Let's take a look inside. The important script is ResNet's control ImageNet main.py. The ResNet control ImageNet main.py script executes the ResNet model. The multicard training can be done either by using Horoward or TF distribute strategy. I'll be using the Horoward in this example. The default values set here are the best configuration for the hardware. We need to get and prepare ImageNet dataset in TF record format. This slide shows the command to get the ImageNet dataset and process them in the right format. Please refer to the README section of ResNet keras in our Model Garden repository for more information. The ImageNet dataset is quite large and will take few hours to download and process. Once the dataset is downloaded and processed into TF record format, it is present in our default directory. The directory can also be altered. Once the ImageNet dataset is ready, we can proceed towards training. To launch the training, we'll be using this command. We train the model using MPI run command, which uses some of its own parameters like -np, which is number of processes, and which is 8 here. And then it runs the resnet main.py file, which has its own parameters like dtype, which is data type, which can be bf16 or fp32, data directory, which is not a mandatory parameter. Provide this only if you have your ImageNet dataset stored in your own location. By default, it picks ImageNet dataset from default location, which is in /data directory. Use horovod flag, as we use horovod for multi-card training. Train epochs, used for setting the number of epochs to train the model. Batch size, for changing the batch size. Optimizer, which can be used and changed to LARS or SGD for training. The other parameters like learning rate, weight decay, and others are self-explanatory, and the values used here is the best configuration. During the training, the graph gets compiled and runs on all 8 workers. It will take several minutes to start seeing the performance numbers on the terminal. Once the graph gets compiled for each card, and if the checkpoint flag is activated during training command, the checkpoints gets created. Every worker will be printing its own individual performance number. The example per second is simply the images per second each card is processing. It is the final performance measured across all the cards. The calculation is done by taking each worker's steps per second, then multiply by batch size, and then multiply by number of cards, which is 8. Thus, it will give corresponding examples per second. We are now at the end of our training. I wish to summarize the process. We first download the ImageNet dataset and pre-process it into TF records format, which is stored in the default location. Then we run the ResNet main script for training and then finally do the evaluation. We'll now go ahead and take a look at the results, which are by default at /temp/resnet folder. Here in the ResNet folder, you can find the output for each worker. Let's go to worker 0. Here, the checkpoints should be saved if the checkpoint flag is activated. This is the standard output for worker 0. You can see the evaluation results stored here across each workers. The evaluation results for worker 0 are present over here. The ResNet Keras model can also be trained for multi-Gaudi card systems like 16 cards and 32 cards. This is all for TensorFlow ResNet Keras training. Don't forget to check out other TensorFlow models from Model References repository. You can also find more information on our website about how to port your own models on Gaudi. Thanks for watching. For more information, watch our website developer.habana.ai.